Since November of 2000, not a day has gone by without humans living in space. After a decade of construction, the International Space Station is a fully functioning colony 225 miles above Earth. Roughly the size of a football field, 100 yards long and 35 yards wide, the massive structure orbits the Earth every 90 minutes. Currently, crews of 6 spend 6-month rotations on board, with astronauts coming from each of 5 major partners: Canada, Japan, Russia, the European Space Agency, and NASA.
The International Space Station really is an icon for international participation in space and for people from different nations working together, peaceful purposes, doing something for the benefit of humanity.
Basically, the station is a series of pressurized cylinders with 4 science labs, crew quarters, and a galley.
And in each of these pressurized labs, they're really very similar to a ground-based laboratory. There are racks of equipment, and this equipment is used for a variety of experiments in biology, chemistry, physics.
Microgravity is the one factor that changes everything and makes a new environment for many different scientific discoveries possible.
We've got plant growth going on. We have fluid physics experiments going on, as well as, guys like me that are the guinea pig where they're studying my muscles and bones. There's a lot of great stuff going on up here.
Science on mineral depletion in bones may lead to new ways to slow down osteoporosis.
On the material side, there's a lot of interest in crystals that are used for the electronics industry, crystals that are used in pharmaceuticals. These tend to grow more perfectly.
One of the experiments on board the ISS developed a compound known as liquid metal. A team from Caltech investigated combining 3 or more metals together in the microgravity environment.
What they did was they used an electromagnetic levitator to suspend this material in free space. And then they melted the material, and because there were no container walls, they were able to solidify the material and measure the thermophysical properties.
Back on Earth, equipped with the data from space, the Caltech team was able to produce bulk quantities of liquid metal, an alloy with characteristics similar to plastic, but with more than twice the strength of titanium.
A discovery, the thermophysical properties, made 17 years ago, takes 10 or 15, 20 years to go from the discovery phase to the marketplace.
On the outside of the station are external Earth and space science hardware platforms. Observation posts along the truss system look out into deep space, searching for origins of the universe. At other points, instruments are turned toward Earth for climate science and space environment studies. Now, with construction finished, some say the real fun begins. John Belmont, Associated Press.